This is Pratik, co-founder of Vacus. Disruption is the word that I would like to start with. Unfortunately, this often means you have to create something even when the world doesn't want it to be. And while creating this indoor positioning and tracking technology, when the entire industry said it was impossible, we made it happen. So we are Vacus Tech Private Limited. We make indoor positioning and tracking devices at an accuracy of 30 centimeters. We started this journey in 2017. The primary reason to start this particular venture was because when we examined the existing indoor positioning and tracking technologies, they particularly failed in terms of the multipath and interference immunity. So when the deployment was pretty large in terms of highly dense environments, the scalability was a big issue and accuracy was pretty inconsistent. We had the problems. When we examined the problems, we had the answers to these solutions. So one of the co-founders, Venu Gopal, he had a couple of patents in wireless communication domain. So we gathered a team of RF engineers and we started working backwards onto the problem. It took us almost 18 months to complete this, but once the technology was ready and proven, we filed for the US patent. Once the US patent was granted, we started the shipping product in the market. Meet configurable radio fence. This is the product that we have created. It basically consists of two parts. One is the transmitter tags and second is the receiver tags. And then there is an IoT software dashboard where the data is being published and seen. Now this transmitter tags is a small device. It's 3.5 by 3.5 centimeter and it consists of an active battery life of around 2 to 5 years depending on the update rate. And then there are different enclosures as per the use case. Right now, Vacus customers are present in enterprise, data centers, and warehousing logistics. So we have tags like personal tag, asset tag, and data center tag. Now this transmitter sends the signal. Now the receivers receive this signal. The receiver basically consists of 12 antenna array sets in an omnidirectional manner. We use angle of arrival method to exactly compute the location. And then we have machine learning and AI algorithms which run on the gateway part of it. The opportunity is big in this indoor positioning and tracking. So the microlocation systems is expected to reach USD 56 billion by the year 2026. And the most important part is it is suitable across 35 different industry segments. It is a 500 million device market, and most importantly, we firmly believe it is going to be an indispensable part of humans or robots' life. Till date, Vacus has been serving customers across enterprise, data center, and warehousing logistics, and we have some big customer names which we have currently engaged with. So we have Vertiv, we have McKinsey and Company, AstraZeneca, Bosch. Primary reason why these customers use our product is for optimizing productivity and safety. And the use cases that we deal in are in asset tracking, there's employee safety and security, occupancy and utilization tracking, parking management, visitor tracking, and in-transit safety. So we have roughly around 10,000 of hardwares which are currently being used by these following customers. COVID hit and the use cases changed a bit. So with the same tags, people now wanted to have an effective social distancing and contact tracing because the other technologies like the BLE and the ultra-wideband, they were inconsistent. The data received was not that great. So with this particular thing, with the same similar tag, we introduced a small buzzer inside the tags and you can completely configure the distance. As we get an accuracy of 30 centimeters, you can configure the distance to 30 centimeters, 60 centimeters, 1 meters or 1.5 meters. Now once you configure and if two people come in nearby contact, immediately the buzzer is being issued so that people can have an appropriate distance between them when they're engaging. Also, there is an effective contact tracing. Whenever people, in case if anyone is detected positive, you know exactly where the people, whom the people and at what time did these guys interact with. On the competitive slide, Vacus CRF is the world's only microlocation technology which has solved the interference immunity issue. We have solved this using our patented technology and the issues that we have solved in multipath and the interference immunity. If you compare to the other technologies like ultra-wideband, beacons and active RFIDs, we are very accurate. The interference immunity has been solved. Scalability is enormous. You can deploy thousands and thousands of tags and the hardware in an environment. The battery life is pretty good and the cost of ownership is very low. This is the intellectual property and the designs on the antenna structures that we have managed to make, and we've received the patent in last year. Till date, Vacus has active customer presence in India, Singapore and Japan. We are looking to expand in the United States in the upcoming few quarters. We have 6 customers account, we have 14 active team members, and we have 1 US patent granted. A couple of patents are more in the filing. As of date, Vacus has a revenue of $250K USD and we're looking to raise $2 million. Our business model is we sell the hardware as one-time capex cost, and then for the software we charge per tag per month basis depending on the use cases and the data analytics required. This is our rockstar team. Venu, who had a couple of patents previously in the wireless communication domain, he handles the tech part of it. I handle the marketing and sales part of it. Bala and Guru, they earlier had a company called Network Solutions, which was acquired by Intel. So they have a rich expertise and contacts in the enterprise domain. Then we have teams which are divided in supply chain, product design, network architecture, and embedded software and the hardware part of it. We are blessed to have partners like Brinc, Maker Village, Intel, Texas Instruments, Lockheed Martin, and Department of Science and Technology as our esteemed partners. Thank you. We are looking forward to connecting.